We'll bring up the presentation here on the screen, and then I will turn it over to Ryan to kick us off from that.
Up there and running. Thank you for letting me have this opportunity, especially in short notice. So hopefully the information is of value today and insightful. Before we get into that, just a little bit about myself. So I've been with Deere over 20 years now, driving innovative solutions there. I managed connectivity for Deere for a number of years across the enterprise. In my prior role, I led a team of folks that led things like autonomy, See and Spray, we'll talk about that, battery electric in small tractors, driving precision ag into a multitude of different production system solutions. I recently took a new role and now will lead the combine and front end equipment business, but still driving innovative solutions. And so today what I actually want to go through is three different areas. First, talking about what are the macro level customer problems that are out there and facing. I always think it's good to start with what's the problem we're solving. If we're thinking about, okay, what's the future of precision ag? Well, let's start with the problems and understand what those are. Then talk a little bit about the technology and how the technology is advancing and how we think about getting that on equipment. And then finally, we'll go through a corn and soy production cycle, and we'll start with planting and then go onto application, harvest, and then tillage, and talk about some of the advancements of technology within each one of those steps. So with that, the first major problem that's out there is we have a growing population. I think we all know this, that our population is expected to grow up to 10 billion by 2050, and with that growing population, we need greater output. But we also know that there's pressures to reduce our inputs, to manage our water, our nutrients, our soil better, and continue to drive for sustainable practices. So as we think about this problem, I really think about it as like, how do you maximize output while reducing inputs, right? And so this is really the first problem that we think about as we look to the future. The next is that growers don't have control over all their variables, and I think it's important to recognize that there's a lot of different variables that a customer has to deal with, or that a grower, has to deal with, and every season, every day, even every hour can look different. And so as we look to the future, how do we think about understanding and helping to gain insight on those variables and provide as much control as we can to the uncontrollable elements of a grower. The next is managing decisions. The number of decisions that a grower has to make on a given day is probably well over 1,000. And there's a multitude of different data streams that are coming together that they've really got a fuse to run their business. And with each decision, there's a question of, do I want to take a risk on this or not? And one wrong decision can really cost an entire season. And so as we think about the future of precision ag, how do we help reduce that risk? A grower has 40 times roughly in their lifetime to get it right. And so how much risk do you really want to take with each one of those chances? How much experimentation is acceptable? And whether that's trying a different piece of equipment, trying a different product, trying a different rate, you name it, there's just thousands of decisions that customers have to make. And the last, they're all doing this within a decreasing labor pool. So there's fewer hands on the farm than ever before. We continue to hear that through our discussions within our working group. And I hear it as I go talk with customers, is this is a large problem that they face, right? So less than 2% of the U.S. workforce is in ag, and it's not expected to grow meaningfully over the next several years. Average farmer is 55 years old and works 12 to 18 hours a day. That's not sustainable, especially with the other challenges that we talked about. So as we think about the future of precision ag, how do we address the labor pool shortage as well? And again, this all boils down to one chance a year. One chance every year to get it right and really understand of how do we help bring the best data and the best solutions to make every year the best year possible. And so for some perspective, that's over 5,000 acres. That's over 750 million plants. So think about if you have a plant at your house and what you do to keep it alive and manage it, and to reach our goals and to really feed our future population, we've got to manage every single seed and every single plant to be truly successful. So that kind of sums up, some of the major themes and problems. I'm sure we've all talked about those in our working groups, and hopefully those resonate with you. The future then is, it's not traditional agriculture that's going to solve this. It's not bigger, faster, stronger. The next frontier is really automated, easy to use, and more precise. Managing every single seed, managing every single drop, being intentional with every single action that happens. On the equipment side of things, we think about it of every job that's executed, is it executed to the best level possible for every single plant? And so I really like this comment here around superhuman performance. So you may think about automation of, okay, when it's time, it goes up or it goes down, or some mechanical thing happens. But really, automation is beyond that. It's how do you take a group of engineers and a group of agronomists and a group of logistics experts and pack all that brain power into a machine and build the context around it to actually automate it. Not just, make the mechanical thing happen, but make it happen for a reason. And so one of the things that I'll talk about is sense, decide, and act. And so how do we get the real-time sensors to make sure that the action, the automation, isn't just a repetitive automation happening, it's an intentional automation based on context of what is happening at that very moment, at that very place where that seed or that plant is located. And all of that, I should say, to increase, while doing that, increase profitability, increase sustainability, and productivity for customers. We can't sacrifice any of that as we go forward, right? So we can't give up productivity for sustainability or vice versa. We've got to bring them all along together. And it's got to be profitable for a grower to drive adoption. So it's a very, very sensitive balance between all three of those for customers. So diving a little bit then into the technology. So as we think about that, we've had things like GPS. However, it continues to get better over time. We continue to make incremental improvements in accuracy. Real-time data, I think, is one that resonates with this group. Connectivity is the foundation for real-time data. But being able to bring the right pieces of data off the machine to a customer and have that equipment on there. Our sensors are evolving and continuing to get better and better. Cameras are playing a much, much bigger role and will play a much bigger role in agriculture going forward. CVML, computer vision machine learning, will be a key to unlock things that we don't even know about today. And then the communication. Again, being the connectivity task force, this all rides along communication. Without communication, the end-to-end automation can't happen, and we can't transform agriculture. And you'll see that in some of the examples that I'll talk about, is that the solutions just won't work without connectivity to the level required, and we will start to have acres where you can adopt the technology and acres where you can't adopt the technology. And connectivity shouldn't be the deciding factor for a grower of whether they can or can't adopt precision ag long term. So diving in a little bit, let's get into planting when we put the seed in the ground. So as we think about, or is the image on the screen here is 36 row unit planter, and think about those as 36 electrified robots going through the field. And those go through the field at over 10 miles an hour. And so there's some amazing technology that's coming where we can look right in the trench as that seed is placed. And so what you see on the lower left-hand side of the screen is the human view. And I think in the room it's a little hard to see, but what you see is the trench, and then the seed is placed in that trench. And the white little speckles around that is residue. On the right side then, you can see the machine view, or the CVML view of that same view. And so what's happening here, as I click, is as the customer goes through the field, seed is placed in the trench, and that camera can see what's happening. It can see, okay, is there too much residue? Is my depth right? Is the soil forming correctly? Is the trench forming correctly? And then we can make a decision and act to change it. So in this, what you saw was an adjustment of the row cleaner by the customer to adjust it based on how much residue is in the trench. But just to give you a little feel of how fast this happens, we speed it up to real time, and it gets a little choppy. But that is how fast it's going. It would be impossible for a human to look at that video feed and make decisions and make any meaningful assessment about what's going on in real time. But with CVML, we can give feedback to the operator and let them know that, hey, you need to make an adjustment. And they then in real time can make that adjustment and then have confidence that their job is being executed the way that they want it to be. So this is just a little view of, in the planting step, of how CVML can help change the future of agriculture. But not only with just placing the seed, placing fertilizer. This product here is called Exact Shot, and so it, as a seed is placed, it places starter fertilizer directly on the seed. Today, that is done with a continuous band or a continuous stream of fertilizer that's placed. By placing it directly on the seed, you can save up to 66% of the product you put down, because you're not fertilizing between the seeds where the plant can't utilize that fertilizer anyways. And so being able to understand when is that seed coming out, timing that to dose that seed precisely is a great example of robotics coming to market to have, not only a sustainable impact on reducing fertilizer by up to 66%, but that same reduction in fertilizer is cost savings and increases profitability to a customer as well. So and then it also raises productivity, because you have to fill up your fertilizer tanks less often as you're planting. And so this is a great example of how do you go after productivity, profitability, and sustainability for a customer, that these solutions are out there and they are possible with the advancements in technology, particularly in robotics. Switching to the next step in the process then, after the corn or soybeans have come out of the ground, and we want to spray them. So this is a sprayer with a 120-foot boom, and it has cameras and vision processing units on it that go through the field, and you can see little spurts of spray coming out, and it is seeing weeds and then only spraying the weeds. And so it can have the impact of reducing herbicide application rates by up to 70% with the same net effect for the grower. And that's all due to the capabilities of cameras and then on-time vision processing units. And the amazing thing about this is that as that camera sees the weed, that vision processing unit decides, hey, that's a weed. It sends a signal to the valve body. The valve opens. Droplets come out of that spray nozzle and hit those weeds in less time than it takes you to blink your eye. And so pretty amazing capability, and this is just the beginning. There's going to be other use cases and applications that we don't know about that will come in other production systems, other steps, other areas, and really it's cameras and VPU and being able to see what a customer could see and then doing it in a superhuman way that will help unlock the future of precision ag. So as we go to the next step, then it's time for harvest. Harvest is a particularly challenging time of year. Heather can probably attest to that she just went through that as we were talking prior to the meeting. A lot of coordination happens. With our combine there, in high-yielding corn, that combine needs to be unloading 40 to 45% of the time to maintain productive. And so that means that grain cart is coming up and going away and coming up and going away on almost a continual basis. And so connectivity is key. Sharing the data, organizing the fleet, anticipating and understanding where everything's happening is really critical to maintaining a productive harvest. And then the last one is maybe the most exciting. We'll talk about autonomy. And this gets into fall tillage, could be spring tillage. And so the image on the screen here is an 8R tractor, and it has cameras on the front and on the back with other sensors on the implement, and then leveraging GPS technology to be able to navigate through the field, without a human operator in the cab. And so this really is the future of agriculture. And so I have a quick video here to give you a customer testimonial about autonomy.
When you start out in the spring, you work the soil, and it just smells so fresh. When you till it up, and it's just the greatest smell. When I started farming, there basically was no technology. Every tractor was driven manually, everything was done manually. You'd be planting, you had to follow a line. If the sun was wrong, you would lose the line. Darkness, you couldn't see your marks. Moisture, you couldn't see your mark. Then you'd get squiggly rows. My name is Doug Nems. I'm a farmer from Blue Earth, Minnesota. I'm a fourth generation farmer, and I raise approximately 2,000 acres of corn and soybeans. I really never thought I would see an autonomous tractor in my farming career. For me, it was really exciting the first time I got to take the autonomous tractor to the field, swipe my phone, watch the tractor start with no one in the cab, start doing tillage, come to the end of the field, turn on the end, do the tillage just as well as I can do myself with no one in the cab. I can pull up the app, I can monitor the tractor, see how much of the field it's got tilled, I can check the fuel level, I can check the app to see how much of the field is left. If there was something in the field that it wasn't sure about, the tractor will stop and alert me. Is this something I can go around? Do I need to go out and remove an object from the field? The app gives me all this information so I can monitor everything very closely. On farms, labor is always a challenge. We need labor for lots and lots of hours for short periods of time. The auto steer and technology has helped reduce our labor load, which makes my life a lot easier. Autonomy will help because we will be able to put a tractor out in the field and let it run for 24 hours a day because it's not manned. But it also helps us with the weather because we can run so hard when soil conditions are fit. The thing that excites me the most about autonomy is not be locked in a tractor cab all day. It will just allow me to run my business better because I can just pay closer attention to other tasks. Now we'll be doing the jobs that we always wanted to get done but never had time to because we were in the cab all the time. Farmers are fairly traditional, but I have a feeling that once they try it, they will become very accepting of it. I think the tractor can do a better job than I can do. Autonomy. It's going to be a life changer for me.
So a couple things to highlight around what Doug said. You know, it allows him to get out of the cab to do a more valuable job. And it allows him to do something they wouldn't have gotten done. And so it frees up time for them. But this really couples with the labor part of it. But the key thing is it couples with the job automation that I talked about from the previous steps, sense, decide, and act. So removing the operator being able to send something autonomously is great, but you also have to know that the job is being executed the exact way that you wanted it executed. And so the combination of these technologies coming together and eventually coming across all the different steps will be what really changes the future of agriculture. And so CVML, just from an autonomy sake, is great, but it's the combination, again, with the automation and understanding the context that really brings both of these together. One quick story about autonomy and connectivity. So we had a customer that actually I was just visiting this past Friday that is a customer that's running autonomous tractors right now for us. And the very first time that she experienced it, we went to her field and the dealer was with her to help get it all set up, and got on the phone into Operations Center and swiped to have the tractor go. The horn and the lights all flash and say, hey, it's all clear. The vehicle starts up and it drives off. And her field had just a little bit of a hill peak in the middle of it, and the tractor drove up over the hill and down, and then they stood there and they waited and they waited with anticipation of, is it going to come back? And it didn't come back. Because the way our system operates is that there's cameras on there and it makes sure it's a safe zone. And with autonomy, if it sees something it doesn't recognize, it will stop. And then through connectivity, it sends that message back to a central command center. Images are reviewed to determine what did it see and can it go forward or not. If for sure not, it informs the grower on their phone that they have a problem, they need to go address it. What happened was it got out of connectivity. So it couldn't send that signal back to say, hey, I have a problem. And so it stopped. And then after so long, the person would have been informed and said, hey, your tractor's out of connectivity. You should go check on it. It might be running, it might not. It just depends if it saw something that it didn't recognize or not. And so I share that as an example of how important connectivity is to the future of precision ag, because as these solutions to continue to advance, and as we make improvements not just with equipment, but all the other elements within the ag ecosystem as well, it's not going to happen without connectivity. We will have acres that can have the future of precision ag and acres without the future of precision ag. And so I'll leave it there and say automation and autonomy is real, it's ready, and it's in market today, but it relies on connectivity going forward. So thank you. Questions or discussion?
Yeah, no, thank you, Ryan. That was awesome. It's exactly, I think, is a perfect presentation for our kind of the last meeting. So I'll open up to questions. So if you have a question for Ryan, if either in the room or online, just raise your hand and we'll let you go. Dr. Adeline has a question. Go ahead, Dr. Adeline.
Thank you. I really appreciate the presentation, but what I was wondering, if you move away from the commodity crops and go to what I would call truck farming, the lettuce, the vegetable types, is there work being done in that area? Because that certainly has a high cost of labor component to it. So what's being done in other areas besides the commodities?
Yeah, thanks for the question, Dr. Adeline. I don't know that I'm the best position to answer that. I know that there's work going on there, but that's not necessarily the core focus for John Deere. We don't manufacture equipment particularly in the harvest step of some of those today. So I would have to defer to that. However, I would say in high value crops, we are participating there. So think of trees or vineyards, tree nuts, vineyards, those types of applications. And then certainly anything that's pulled with a tractor, investigations are happening as well.